Okay, in this tutorial now we'll be looking at indicial equations. So these basically make use of our index laws, which I have written down here. So all of these should be familiar to you already. So we have a to the power of m times a to the power n gives us a to the m plus n. If we go a to the m divided by a to the n, then it's a to the m minus n. We have a to the power of m to the power n, then that's a to the power of mn. If we have a times b to the power of m, well, that's a to the power of m times b to the power of m. If we have a divided by b to the power of m, then it's a to the power of m and b to the power of m, and we just need to be careful to not let b equal 0. If we have a to the power of 0, that's equal to 1, and again, we don't want to have a equaling 0, okay? But basically any other number to the power of 0 is always 1. A to the power of negative m is 1 over a to the power of m, and again, a can't be equal to 0. If we have a to the power of 1 divided by n, then that's the nth root of a. So for example, a to the power of a half, so 1 over 2 is the square root. A to the power of 1 over 4, fourth root. Okay, if we have a to the power of n divided by m, now there's actually two ways we can talk about this. We can say that it's the nth root of a to the power of n, or it's the nth root of a to the power of n. Okay, either way. Sometimes it's better to use this one, other times it's better to use that one. Okay, so it's really just utilising these index laws now. So we've got a few worked examples we can do. Okay, so we need to solve 4 to the power of 3x plus 16 to the power of 3 minus x equals 256. Okay, straight away there, what I'm thinking is I can see that 16 is the power of 4 and so is 256. So we're going to represent them all as the same base. So I'm going to go 4 to the 3x times 4 squared to the 3 minus x. Okay, and we can say that we've got 4 to the power of 4. Okay, well this one we can leave as 4 to the 3x. Okay, and when we've got this here, this is our case here. Okay, so we're going to multiply them together and say that we've got 4 to the power of 3 times 2 is 6. Take 2 times x is 2x equals 4 to the power of 4. Okay, now that we're multiplying things in the same base, okay, we can add our powers. So now we've got 4 to the power of 3x plus 6 take 2x equaling 4 to the power of 4. Okay, so we can say that we've got 4 to the power of x plus 6 equaling 4 to the 4. Okay, now that we've got to this stage, what we can do is we can equate our powers and say that we have, well, x plus 6 has to equal 4. Okay, therefore x has to equal negative 2. Okay, so we'll flip over to our next page with a couple more worked examples. Okay, so we've got 7 to the power of x minus 3 equals 0. Okay, so what we're going to do is we're just going to bring our 3 across to start off with and say that we've got 7 to the power of x minus 3 equals 3. Okay, now because there's no way of getting our 7 and our 3 to be the same base, what we do is we use logs. Okay, so we do our loopy method. We say log to the base 7 of 3 equals x take 3. So we go log to the base 7 of 3 equals x minus 3. Okay, therefore x equals log to the base 7 of 3 plus 3. Okay, really important example. Can't do a lot when our bases aren't the same. Okay, and can't be made the same. Okay, so, and that's our answer, okay, because that's an exact value. Don't forget, log to the base 7 of 3 is an exact answer. Okay, so if we look here, okay, at this one, okay, it's tempting to multiply out our brackets, but we don't need to because they're equal to 0. So really, we've got a null factor law sort of question where we're saying this is equal to 0 or this is equal to 0. So we're going to say we've got 5x take 25 equals 0, or 5 to the x plus 1 equals 0. Okay, so we'll work with this side first. We're going to say, well, 5 to the x equals 25. So we can say 5 to the x equals 5 squared. Therefore, x equals 2. Okay, and for this side, okay, we've got 5 to the x equals -1. Well, that doesn't work. There's no solution. Okay, and again, we could try to do our looping method and go log to the base 5 of -1 equals x. So go, well, bingo, x equals log to the base 5 of -1. But hang on, logs can't be negative. Logs can't be negative. Therefore, no solution. Okay? We've got one last example. Okay, I don't think I've actually done this before, but I've actually said it's a super important example. Okay, and this has come up on exams in the past, it'll probably come up on an exam again, whether it's actually in the terms of a exponential question or whether it could be a quadratic or a polynomial type question. Okay, but it's a very, very important process to do. Okay, and it's a little bit harder to see in exponential questions like this, or index questions like this, sorry. Okay, because we've got 3 to the power 2x, take 9 outside 3 to the power x plus 14. The key bit here is that they said here in our brackets 3 to the power of x. So what we're going to do here is go let a equal 3 to the power of x. Okay, now that doesn't seem like it's going to help very much. Okay, but here, okay, what that means is we can make it 3 to the power of x squared, take 9 times 3 to the power of x plus 14 equals 0. Okay, that's a really important step. Okay, because when we do this substitution in here, it's going to look a lot nicer. Now we've just used our index law from before. Okay, when we've got this, okay, we multiply through, so we're using it in reverse. Now we have a squared take 9a plus 14 equals 0. Okay, and we can factorise that to be a take 7, a take 2 equals 0. Okay, so we null factor law and say that we have a minus 7 equals 0, or a take 2 equals 0. Okay, so we can say, well, a equals 7, or a equals 2. Okay, now we can do our substitution back in and say, well, we've got 3 to the x equals 7, or 3 to the x equals 2. Okay, so then we do our looping method, so go log to the base 3 of 7 equals x, put log to the base 3 of 7 equals x, or log to the base 3 of 2 equals x. Log to the base 3 of 2 equals x. Okay, and so we're finished off. Okay, so that's all we've got for this section. So there's not too many questions in this section, and look, a lot of it was seen before, so hopefully you'll fly through these questions.